for estimating the amount of wire needed for a 5,000 square foot house, a rule of thumb is to use approximately 1,500 feet of wire per floor. This accounts for both the outgoing circuits and their corresponding return paths. Keep in mind that this method relies on several assumptions. Firstly, that the house has 2 floors, each with an area of about 2,500 square feet. Secondly, the wire will primarily run within the walls and ceilings. Thirdly, the wiring will consist of 14 gauge or 12 gauge NMB cable, which includes a ground wire. Based on these assumptions, the calculation is straightforward. If you have 1,500 feet of wire needed per floor, and the house has 2 floors, then the total estimated wire needed will be 3,000 feet. However, it is important to consider additional factors that can influence the final wire requirement. This 3,000 foot estimate is a rough approximation. The actual amount of wire can vary based on the house's layout, the number of electrical outlets and switches, and the location of the main electrical panel. Furthermore, this estimate does not include the wiring for special purpose circuits. Special purpose circuits serve specific high demand appliances such as the range or oven, electric dryer, dishwasher, and electric water heater. Each of these appliances will require a dedicated circuit with its own wiring. For example, a range or oven circuit might need approximately 6 to 8 feet of wire. An electric dryer circuit could require around 5 to 7 feet of wire. A dishwasher circuit might need 4 to 6 feet of wire, and an electric water heater circuit could need 10 to 15 feet of wire. You also need to factor in extra wire for making splices and any potential repair work that might be needed in the future. It's generally a good practice to add a bit of extra length to each run for these purposes. To illustrate this, consider a 5,000 square foot house with these special purpose circuits, an electric range, gas dryer, dishwasher, and an electric water heater. The basic wiring, calculated as previously described, would require around 3,000 feet. The range circuit let's estimate at 8 feet, the dishwasher circuit at 6 feet, and the water heater circuit at 15 feet. Summing up all these lengths, the total estimated wire needed for this particular house would be 3,029 feet. It's always better to overestimate than underestimate the amount of wire you will need. Having extra wire on hand will prevent delays and ensure that you have enough to complete the job properly. When running electrical wiring in a house, safety is paramount. It's crucial to adhere to all relevant electrical codes and regulations. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Incorrect wiring can lead to electrical shocks, fires, and other hazards. Firstly, familiarize yourself with the National Electrical Code, or NEC. The NEC provides comprehensive guidelines for electrical installations, covering everything from wire sizes to circuit protection. Secondly, always turn off the power to the circuit you are working on. Use a voltage tester to verify that the power is off before you begin any work. Thirdly, use the correct size wire for the circuit. The wire size must be appropriate for the amperage of the circuit. The NEC provides tables that specify the appropriate wire size for different amperage ratings. Fourthly, use the correct type of wire for the application. NMB cable is commonly used for residential wiring, but other types of wire may be required for specific applications. Fifthly, make sure all connections are secure. Loose connections can cause arcing, which can lead to fires. Sixthly, protect the wires from damage. Run wires through walls and ceilings using appropriate methods, such as using conduit or cable staples. Seventhly, properly ground all electrical boxes and equipment. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Eighthly, use the correct type of circuit breaker or fuse for the circuit. The circuit breaker or fuse must be sized appropriately for the amperage of the circuit. Ninthly, label all circuits clearly. This will help you to identify the correct circuit in the future. Tenthly, inspect your work carefully after you have finished. Make sure that all connections are secure and that all wires are properly protected. Electrical wiring involves various components, each with a specific function. Understanding these components is essential for safe and effective wiring practices. Firstly, electrical panels. The electrical panel is the central distribution point for electricity in a house. It contains circuit breakers or fuses that protect the circuits from overloads. Secondly, circuit breakers. Circuit breakers are safety devices that automatically interrupt the flow of electricity in a circuit if an overload or short circuit occurs. Thirdly, fuses. Fuses are another type of safety device that protects circuits from overloads. Fuses contain a thin strip of metal that melts and breaks a circuit if the current exceeds a certain level. Fourthly, wires. Wires are used to conduct electricity from the electrical panel to outlets, switches, and appliances. Wires are typically made of copper or aluminum. Fifthly, outlets. Outlets are points where electricity can be accessed to power appliances and other devices. Outlets come in various types, including standard 120 volts outlets and 240 volts outlets for high power appliances. Sixthly, switches. Switches are used to control the flow of electricity to lights and other devices. Switches come in various types, including single pole switches, three-way switches, and dimmer switches. Seventhly, junction boxes. Junction boxes are enclosures that protect wire connections. Junction boxes are required at all points where wires are spliced or terminated. Eighthly, conduit. Conduit is a protective tubing used to run wires in exposed locations or underground. Conduit can be made of metal or plastic. Ninthly, cable staples. Cable staples are used to secure NMB cable to studs and joists. Tenthly, grounding wires. Grounding wires provide a path for fault current to flow back to the source, which helps to protect against electrical shock. Grounding wires are typically made of copper. When selecting wire sizes for different circuits, refer to the NEC tables. These tables specify the minimum wire size required for a given amperage rating. For example, a 15 amp circuit typically requires 14 gauge wire, while a 20 amp circuit typically requires 12 gauge wire. For circuits with higher amperage ratings, larger wire sizes are needed. For example, a 30 amp circuit typically requires 10 gauge wire, and a 50 amp circuit typically requires 6 gauge wire. The NEC also specifies the ampacity of different wire sizes. Ampacity is the maximum amount of current that a wire can safely carry. Exceeding the ampacity of a wire can cause it to overheat and potentially start a fire. When making wire connections, use appropriate connectors and techniques. Wire connections must be secure and properly insulated to prevent short circuits and electrical shocks. Firstly, wire stripping. Use a wire stripper to remove the insulation from the ends of the wires. Be careful not to damage the conductors. Secondly, wire splicing. Splice wires together using wire connectors or crimp connectors. Make sure all the connections are tight and secure. Thirdly, wire termination. Terminate wires at outlets, switches, and other devices using screws or terminals. Make sure the connections are tight and that the wires are properly seated. Fourthly, insulation. Insulate all wire connections with electrical tape or wire connectors. This will prevent short circuits and electrical shocks. Fifthly, grounding. Properly ground all electrical boxes and equipment. Connect the grounding wire to the grounding terminal in the electrical box and to the grounding screw on the equipment. When running wires, follow these guidelines to ensure safety and compliance with electrical codes. Firstly, avoid sharp bends. Avoid making sharp bends in the wires, as this can damage the insulation. Secondly, support the wires. Support the wires at regular intervals using cable staples or other approved methods. Thirdly, protect the wires from damage. Protect the wires from damage by running them through conduit or other protective materials. Fourthly, avoid running wires near heat sources. Avoid running wires near heat sources, such as furnaces or water heaters. Fifthly, avoid running wires near water pipes. Avoid running wires near water pipes, as this can increase the risk of electrical shock. When working with electricity, it is essential to use the appropriate tools and equipment. Firstly, voltage tester. A voltage tester is used to verify that the power is off before you begin any work. Secondly, wire stripper. A wire stripper is used to remove the insulation from the ends of the wires. Thirdly, pliers. Pliers are used to grip and manipulate wires. Fourthly, screwdriver. A screwdriver is used to tighten and loosen screws. Fifthly, electrical tape. Electrical tape is used to insulate wire connections. Sixthly, wire connectors. Wire connectors are used to splice wires together. Seventhly, crimp connectors. Crimp connectors are used to splice wires together using a crimping tool. Eighthly, fish tape. Fish tape is used to pull wires through conduit. Ninthly, drill. A drill is used to drill holes for running wires. Tenthly, safety glasses. Safety glasses are used to protect your eyes from debris. In addition to the rule of thumb for estimating wire length, there are other methods that can be used. One method is to use a wire measuring tool. A wire measuring tool is a device that measures the length of wire as it is pulled through it. This can be a useful tool for accurately determining the amount of wire needed for a project. Another method is to use a wire estimating software program. These programs can help you estimate the amount of wire needed based on the dimensions of the building and the layout of the electrical system. Remember that estimating wire length is just one aspect of electrical wiring. It's crucial to consider other factors, such as circuit design, load calculations, and safety requirements. If you are not comfortable with any aspect of electrical wiring, seek professional assistance. Always prioritize safety and adhere to all applicable codes and regulations. The total length of wire that is needed depends on how many outlets, lights, and appliances are planned for the home. To get a more accurate estimate, you should create a detailed electrical plan that shows the location of all electrical devices. This plan will help you determine the length of each circuit run. When calculating the length of each circuit run, be sure to add extra wire for connections and to account for any obstacles that may be in the way. It is also a good idea to add extra wire for future needs. In addition to the length of the circuit runs, you will also need to consider the size of the wire that is required for each circuit. The size of the wire is determined by the amount of current that the circuit will carry. The NEC provides tables that specify the minimum wire size required for different amperage ratings. It is important to use the correct size wire to prevent overheating and electrical fires. When installing electrical wiring, it is important to follow all safety precautions. Always turn off the power to the circuit that you are working on. Wear safety glasses and gloves. Use the proper tools for the job. If you are not comfortable working with electricity, hire a qualified electrician. By following these tips, you can estimate the amount of wire that you will need for your home and install the wiring safely and effectively. Remember that this estimation is a general guideline, and consulting with a qualified electrician is always recommended for accurate assessments and safe installation.